Hi, this is Module 6, Video 3. In this video we're going to build our exercise program view model. Just before we get to today's view model, I wanted to discuss a couple of things about the exercise programs view model that I did in the last video. First of all, you'll notice I've changed it so that it's far more reactive. So all the code that we had that was imperative in event handlers and what have you, and the kind of private observables that we had has been moved into the constructor, and I'm progressively building up the more complicated observables that we need. So, I'm starting with the documents from cache, which was formerly a property, documents from cloud, combining them together to create this documents variable, and then save documents where it catches any exceptions. And then I'm taking those and further composing them into the various bits and pieces that we need. And now our code down here is far simpler. We're just returning the observable as property helper values. And also, we don't have the private event handler with all the imperative code in there anymore. I did swap the tuple for this document source with class, which allows you to store an item with a document source. Not ideal, but there's no record type. Again, I wish C# had a record type that I could use there, but that will do. So that's one thing I wanted to draw attention to. The other thing was I didn't make it terribly clear in the last video, the fact that we're using our exercise document service, exercise document observable, to kind of drive the population of our model and our exercise programs. That implies that if the user makes a change to their exercise programs, it will automatically propagate through to this view model, and in turn it will propagate through to the view. So the idea, of course, is that you could have the application open on your iPad or iPhone, looking at the exercise programs, and then you could go off to your Mac and make a change to the exercise program document, save it, and then moments later the changes will appear in the app. So I just wanted to make that clear that that's kind of infrastructure is in place now. The only other thing we need to do, of course, is to tie it into the views with some bindings. Okay, so moving on to this video's exercise program view model. You remember I stubbed that out for the purposes of the previous video, but I didn't create a unit test harness, so let me do that. Okay, and the public API for this view model, if you think about how it's, what it represents an exercise program, and this is kind of where the rubber meets the road for our application. This is the thing that the user cares about. It's the thing that they start and stop and skip through and etc. So it's going to need properties around, whether it's running or paused. So in the view, I think we'll just have separate buttons for pausing and playing, and then just hide the one that isn't relevant for the current state of the view model. So to make it easy for the view, we can just have Boolean properties saying whether the start is visible, whether the pause is visible. And if you think about it, there is a difference between starting for the first time and starting after being paused, because if you're starting after being paused, you're just resuming, and all you need to do is kind of unpause the execution context. Whereas if we're starting, we need to create a new execution context and start afresh. So I think I'm going to separate those concepts out as well, just to make it easier to implement the view. And in fact, the view model as well will be simpler to understand if we separate these things out instead of trying to lump them all into one thing. Okay, and we're also going to need, some basic information about the exercise program itself, and perhaps that should go above this stuff, like its name, duration, etc. Okay, so I've got name, duration, progress as a double, so we can easily kind of calculate where we're up to as a fraction of the overall duration, and then based on that we can calculate a time span. And of course the view may actually use this one. I'm not sure yet. This one may be superfluous, and we may be able to get rid of that. I've also got a list of exercises, of course, because we'll probably want to show the user all the exercises in the exercise program, and I just need to create this as a stub for now. And then of course we'll probably want to show them which exercise they're up to as well, so we should expose that. So on top of those, we probably just need some commands to allow the view to control what the view model's doing. So those are the commands I can think of that we'll need: starting, pausing, resuming, skipping backwards and skipping forwards. So I think that's probably sufficient for the public API. I'm going to start with some very simple tests around these properties that just return whatever's in the model, and then progressively, get into the more complicated stuff as we go along. Okay, so here's my starting set of tests. We know we're going to need to take a model from our view model, so I'm asserting that we throw if that's null. The name property in the view model should match whatever name is in the model. That's what I'm testing here. Likewise for duration, and whatever exercises are in the model should be exposed through the view model as well. Now I've got these assertions at the end here that are commented out because our view model, our exercise view model doesn't currently have a name property because we've just stubbed that out. So I can enable these assertions later. So the implementation of that should be pretty straightforward. And now that we've changed our constructor in the exercise program view model, we need to go back and update our exercise programs view model to pass through the model to the view model, which we can just do by passing through Y here. And that also means that we can go back and enable that assertion that we had disabled for our exercise programs view model fixture. This one here. So I'm missing my link import. Okay, so let's try that. Hopefully our test will fail. Okay, all our exercise program view model tests are failing, but we've also got failure here now because we haven't implemented the name property yet, so that kind of makes sense. So now let's implement that basic functionality. There we go, and the only real thing to note here is we need to convert the collection in the model of exercises, collection of exercises in the model to a reactive list of view models. So I'm just using create derived collection again. And again, this will break later when we flesh out the exercise view model, because we'll need to pass through this model object to the exercise view model. But for now, that should allow us to pass our tests. Cool, all passing. Okay, so next up, let's think about how we do progress. And I think I actually said this the wrong way around before. If I put this first, think about that as the first thing we can get a hold of, because our execution context already kind of figures out a time span for us. But the double here is for the benefit of the view, because it's going to be using like an activity bar or progress bar, whatever they're called in iOS, and that will require a fraction, a number between 0 and 1, where 0 represents 0% and 1 represents 100%. So we need to calculate this based on this. And in order to know where we're up to progress-wise, we need some kind of execution context. And the execution context, of course, can change throughout the course of the program, so we'll probably manifest that as a property which we can then observe. But first of all, how do we test this? Because ultimately what's going to make the progress change is pausing and playing the execution context, which is tricky because we don't have our pause and play commands yet. So actually maybe we should concentrate on tests around the commands and then kind of take it from there, because that will probably drive everything else. So let me write some tests around the start command. So here's a couple of simple tests to get started with. First of all, make sure that isStarted is false by default, which of course is directly tied to our start command, so that's why I'm starting with isStarted. And then isStarted cycles correctly if the start command is executed. So what I'm basically doing is executing the start command and then making sure that isStarted changes from false to true and then back to false again, which makes sense because when the exercise program completes, it's no longer started. That's what we would expect anyway. And if you're a bit confused by this, then basically what we're doing is checking when the isStarted changes, taking 3 of those changes, which is all we expect, converting that to a list. This is an extension method I wrote previously, which defaults to a 3-second timeout. So if we don't get these 3 values within 3 seconds, then the test will fail. Converting that to a task so that I can await it later, and then I'll do the execution and the rest of the logic there. So I think this is a good spot to start. I don't want to, I'm not 100% confident this test is even correct yet, so I'd rather make sure the tests fail and then see if we can get these tests to pass. Okay, we've only got the one failure because of course it started is false. So let's have a think about how we would write this code. We're going to need, as I said, some kind of execution context property that can change over time. So let me start there. And based on that, we could actually use that as a trigger to know whether we're started or not, because if the execution context exists, i.e. it's not null, then we have actually started the exercise program. We may be paused, but those two concepts, I think we'll keep them separate actually. So you can be started and paused, in which case you can resume, but you can't start again. Yeah, I think that makes logical sense. I mean, the naming's not the best, but I can't come up with anything better right now. So basically we can drive our isStarted property on that, from that. So let's do that. And actually one other thing I should get out of the way sooner rather than later is dispose support. So this is the basic idea: is we check when any value, when the execution context changes, and then if it's null, then we're not started, otherwise we are. And then we just call to property on that, add it to our disposables. So now we need something, oops, I forgot to create the disposables. Right, so now we need to actually expose this start command and do something when it's executed. So and when we do something, it's going to need to be asynchronous because our whole model is asynchronous. So we use this create async task method. I can never decide which is the best way to format with this on the same line like this or on the next line like this. I think I'm going to go same line. Okay, so start command can only execute if we're not already started, and it's going to execute this on start, which I should probably call on start async. So now we can return that start command from our property and do something in the on start async. And what I typically do if with the command handler is I'll just kind of forward it on to another handler that doesn't take the state because or takes converted state, just because I think that's a bit cleaner. And in terms of what start needs to do right now to pass our tests, I guess it just needs to create the execution context, a new execution context, and it needs to await the execution of the exercise program using that execution context, of course. And then finally it can clean up once it's done. And I might just make this a bit more thread safe. So, not that it should matter, but I think it's just a bit clearer, a bit safer by doing that. And oh, of course that's wrong. That last one should not be like that. Should be setting the property. And we probably, I mean, we don't need to handle it now, but cancellation, if this gets cancelled, we'll get an exception. But hopefully our test will kind of flush that out later. That in theory is enough to pass our current test because the creation of the execution context or the assignment of the execution context here should update the isStarted property, and then of course we reset it here, so it should reset back to false. One thing that concerns me here is I haven't used a scheduler here, so I should take a scheduler service and make sure that we're doing this on the correct thread. Like that, and that probably also implies that our test won't work because I'm not doing anything to kind of pump through those values, but we'll get to that. And in fact, we're probably in a position now to run the test. Not quite. We've got this constructor problem here, of course. Okay, so we are failing, and you notice that it took a few seconds to fail, which implies this timeout. So my gut feeling there is because we're running this on a separate scheduler and nothing is kind of pumping through those nothing is pumping that scheduler. That's why the test is failing. So let me make some changes around that. You may remember way back when I put the test scheduler service together, I added a pump method on there to kind of pump through or pump the scheduler. And this is precisely the scenario that I've found that useful in, because you don't want to have to call start over and over again yourself in the test. You just kind of want to just keep pumping it until some condition is met. In this case, this await succeeds. So what we're going to do is just wrap this whole thing in a called pump like that, and hopefully that will resolve the issue. Nope, still failing, so let me look into this. Okay, I'm just back from debugging that problem and watching some cricket. And the problem was, as per usual, my own stupidity. I was returning false from here, so all we had to do was dereference the value property in our observable as helper property, and now if I run those tests, everything works, including our test here. So now we can move on to something else. I think the first obvious thing to do here is to kind of mirror these tests and instead test the isStartVisible property. And of course its behavior is basically the opposite of the isStarted property. So we expect it to cycle through true, false, and then true once the exercise program completes. So let me ensure those tests fail. There we go, both failing. And the implementation here should be straightforward. So all I'm doing for isStartVisible is just taking the canExecute observable from the start command and using that, or kind of exposing that as a property called isStartVisible. Now everything's passing. So we probably now want a similar set of tests for isPaused, isPauseVisible, isResumeVisible. So let me do those. Okay, so I've added a few different tests around, is pause visible, is resume visible. I'm pretty sure they're not correct yet. I mean, certainly, for example, in these cases where I'm executing pause, I believe I'll need some kind of exercise that actually takes up time. Otherwise, as soon as we start, it's going to complete straight away, so there's nothing to pause. But, I'll worry about that when we get to that. So I want to see these failing now and then look at the implementation and then see if they pass. Okay, so they are all failing as we had hoped. So let's have a look at the implementation. And most of this is going to follow a similar pattern that we've already established here with the start command and start visibility. Okay, so what I've done here is pause is calculated based on the execution context is paused property. So if the execution context changes, we want to grab a new observable that tells us when the is paused property changes. Now, if the execution context has changed to null, that means obviously we can't pause, so I'm just returning observable.return false and switching to whatever observable we get back, and then converting that all into a property. And the is pause visible, is resume visible stuff is exactly the same as it is start visible, except our commands are a bit simpler, and determining whether we can pause the command is based on whether we're already started and whether the execution context is paused. So if we're started and it's not paused, then we can pause. If we're started and it is paused, then we can resume. Now I am missing here some logic to execute when the command actually executes, so let me add that quickly. So obviously all we need to do if the pause command is executed is to pause the current execution context, and likewise resume just unpauses it. So that is hopefully the correct implementation. I've got a couple of errors here. I think I'm just missing a using statement. Actually, I've run into this before. It's because iReactive command doesn't implement. I don't think it implements observable. No, so we need. I think we need reactive command of object here. It's unfortunate, but I think that's required. Yep, that's building. So let's try those tests. I've still got quite a few failures, and I rather suspect this is because of the issue I mentioned earlier. So I'm going to take a look at this offline and then fill you in. Okay, so I fixed all the tests. Here you can see they're all passing. It turned out to be a bit hairy. Basically, there was a race condition in certain scenarios So for those tests, I've changed the approach so that instead of kind of collecting all the expected values into a list, I'm kind of checking each value as we go along. So for example, in this scenario, is pause visible cycles correctly if pause command is executed? The first thing I do is wait until is pause visible is false, and then I execute the start command, wait for the is pause visible to become true, and then execute the pause command, and then wait for it to become false. And all of these have a timeout, so that if any one of them fails, it'll fail within 3 seconds. So that's fixed all those issues. So now we've got pausing, resuming, and starting kind of covered with our tests. Next up, I want to ensure that the progress property is working as expected. So I'll write some tests for that. Okay, so there's 2 tests failing, as you just saw. Each one has an action which, when executed, will add some progress onto the execution context. A couple of different calls there just to, to test this out a bit more. And then we listen for 3 changes to the progress time span property. And then we make sure that we start with 0 and then we go to 1 second and then 4 seconds because 1 plus 3 is 4. And likewise for the progress, which is a ratio between 0 and 1. So in this case, the total time for the action, which we actually need to specify here. So the total time is 1 minute. So when we add on 15 seconds, that's a quarter, so 0.25, and then we add another 30 seconds, that's 3/4, so 0.75. So the code for this is going to be similar approach to what we've taken already, of course. Okay, so that's the implementation that I'm hoping will work. Again, taking a similar approach to what we had before, where checking when the execution context changes, and when it does, we grab the observable of the progress property within, using a time span of 0 if there is no execution context. We switch to that new observable, and then we convert that to our property progress time span. And then progress, essentially what we need to do is calculate the ratio of milliseconds through our progress divided by the total milliseconds of progress for the entire exercise program. So that's what we're doing there. Let's try the tests. Both failing, so I suspect there's something wrong with the tests, as has been the case. So let me take a look at that. Okay, that problem turned out to be a bit of a doozy, but as you can see, it's working now. It looks like it might be a bug in reactive UI actually, because all I've changed to get this to work after a lot of debugging is instead of using observable as property helper here, I'm just setting and getting this, or setting in this case, this property directly instead. So previously we had this code, this is our execution context by the way, and this code would scan the progress deltas to sum them up, and then it would call to property to assign it to the progress property. I found that this observable was ticking, but it wasn't being reflected in the property immediately, and I couldn't get it to reflect at all, which is why the test was failing. So I've changed it over just to simply set the property directly. So we now have a property with a getter and a private setter, and not using observable as property helper anymore for that particular property. And that works. Now I may post this on the Reactive UI forum just to see what the heck is going on here, see if I can come up with a repro, standalone repro that that reproduces this issue. But for now I'm going to leave it at that because this video is going on forever. So I'm going to move on now to the next piece of the puzzle, and this is probably actually the most complicated piece of this view model, is the skipping forwards and backwards. Not that it's terribly complicated, it's just particularly skipping backwards is a bit more complicated than you might expect, because we need to distinguish between two cases. One is the case where the exercise that you're skipping has only just begun. So in that case, skipping backwards means you probably want to skip not back to the start of that exercise, but to the start of the exercise before that exercise. And the other case, of course, is when the exercise has been, been playing for a while, whether that's 3 seconds or whatever we decide to make it. And in that case, you probably want to skip back to the start of that exercise, not the exercise before it. And consequently, the availability of the skip backwards command has to take all that into account. Skipping forwards is a bit easier because we're just going to the next exercise if there is a next exercise. And in both cases, we probably need to recreate the execution context with the appropriate skip to parameter, so it skips the correct point in the exercise program. So all this is a bit complicated, and I'm probably gonna write, I don't know, 5 or 6 tests around this. And rather than make you watch me type it all, I'm going to pause this and then show you what I've typed afterwards, because it's probably going to take quite a while. So let me do that. Okay, I've written a set of tests here. I'm kind of glad I didn't make you sit through that because that took quite a while. But I will walk you through them quickly. And they are more complicated than I would like, but right now I don't have time to simplify this. Hopefully later on I can do so. So first of all, we've got skip backwards command is disabled if on first exercise. So this, I'm using a new technique here that I've just come up with, and maybe I'll retrofit this onto some other tests, but I've got a mock action, and when it executes, it returns a task which pauses the execution context and then immediately awaits while it's paused, which basically means that action never completes. So it's a convenient way to make sure that the execution of the exercise program never completes, and it's kind of stuck in this action as soon as you execute the exercise program. Alright, so then I do the usual setup here. So I then immediately start and then pause the exercise program, and then that is actually unnecessary now. Whoops. Because I'm pausing from the action. And then I'll wait until it says it is paused, and then and at that point I can check to make sure that the skip backwards command can't execute, which makes sense because we're still stuck in the first action of the first exercise, so skipping backwards just doesn't make sense at that point. Skip backwards command is enabled if sufficient progress has been made through the first exercise. So you're still in the first exercise, but you've made enough progress through, which I've called 1 second here. I don't know if we'll need to tweak that later. But the idea is if you've made enough progress through that exercise and you press the back button or the skip backwards button, it will go back to the start of that exercise. So all I'm doing in this test though is making sure that once we've added enough progress on, the skip backwards command becomes available within 3 seconds. Obviously we would expect less than that, but that's the standard timeout. So skip backwards command restarts the execution context from the start of the current exercise if sufficient progress has been made. I might rename that, it's a bit of a mouthful. But the idea is if we've made enough progress through the exercise and then we execute the skip backwards command, we expect to go from where we currently are, 4 seconds here because I've added on 4 seconds of progress, back to the start, which is 0 in this case. Skip backwards command restarts the execution context from the start of the previous exercise if the current exercise is only recently started. So in this case we're only progressing half a second through the current exercise. So when we skip backwards here, we expect to go back to the start of that exercise, not to the very start, not to the start of the previous exercise. So we're starting at 0, and then you see here I'm starting from the second exercise, which I'll explain in a second. So we immediately jump to 10 seconds into the exercise program because our action duration is 10 seconds. And then we progress half a second, so we expect 10.5 seconds, and at that point we're skipping backwards. So we expect to go back to the start of the previous exercise, not the current exercise. So we go all the way back to 0, not to 10 seconds. Now this thing here needs some explanation. I've decided to make the parameter to the execute method the starting point of where you want to execute from. Obviously I haven't implemented that yet, and hopefully it all works out, but that's the idea here is we're definitely going to need to be able to start from a certain point, internally at least, and in this case I need to expose that externally so that the test code can exercise the scenario that it needs to. So the next test, skip forwards command, is disabled if on last exercise. Kind of self-explanatory. If you're on the last exercise you shouldn't be able to skip forward. So I've got a single exercise using that same trick with pausing. Waiting for the skip forwards command. Sorry, I've got 2 exercises. That's why I was getting confused here. So they're both running the same action though. So we start up the exercise program, we wait until we can skip forwards, then we skip forwards, and then we make sure that we can't skip forwards after that because we're on the second exercise, which is the last exercise. Skip forwards command skips to the next exercise, also self-explanatory. And in this case I'm using progress to make sure it's skipped to the next exercise. So here we're skipping forwards from exercise 1 to 2, which means our progress should go from 0 to 10 seconds because they're 10-second exercises. And lastly, I thought I may as well test the current exercise property as well, as best I can anyway. And in this case I've got 3 exercises and I'm doing a bunch of skipping around, so I'm skipping forwards a couple of times, maybe 3 times, and then skipping backwards. And then all the while I'm kind of monitoring the current exercise property and collecting them into a list. And the idea is once we've fleshed out our exercise view model, it'll have a name property, and I'll be able to I'll be able to enable these assertions to make sure that we're going from exercise 1, 2 to 3 and then back to 2. So those are the tests. They are all failing. I have run them, so you can take my word on that. So let's get to the implementation. Oh, and by the way, this is something I added a bit earlier when I was debugging. All I've done is added a handler to all the command thrown exceptions observables, and all that handler does at the moment is just spit out to system-diagnostics.debug the exception. I will at a later time swap in our logger service to be more consistent and correct. Now this implementation is probably going to be pretty involved as well, so I'm not going to kind of talk as I do it. I'm going to do it and fast forward through that and then explain what I've done. Okay, so here's what I've come up with. Defined a couple of new commands here, and I've got this can skip backwards observable, which uses both the execution context and the progress time span to determine whether we can skip backwards. And basically the progress has to be greater than or equal to this skip backwards threshold, which I've set to 500 milliseconds, and we'll see how that goes when we're interacting with the app. Maybe that's too quick, I don't know. And of course the skip backwards command executes an on skip backwards async method. Can skip forwards is a bit simpler because all we need to do is check whether the current exercise is not the last exercise. And likewise it executes this on skip forwards async. So on skip backwards async forwards the call onto skip backwards async. And this is probably the more complex one. It's grabbing a bunch of information we need here: total progress, current exercise, and whether we're paused. It's looping through the exercise to try and find the exercise that's before the current exercise, so the prior exercise. And then it waits this stop async, which is another new method which stops the current exercise program. And then it does this calculation to figure out where we need to skip to. And that's really the crux of this method, because it takes into account the skip backwards threshold to determine whether we're skipping to the start of this exercise or the start of the prior exercise. And of course we need a prior exercise in order to do that, so it makes sure that that's not null. And then we call start async, which I've supplemented with two new parameters. One is where we're skipping to, and the other is whether the execution context should be paused or not. Because I was thinking, if you're currently paused, you still want to be able to skip forwards and backwards, but doing so shouldn't change the state of whether we're paused or not. So if you pause and you skip forwards, it's still paused. So all that happens with those parameters is they're passed through to the execution context directly. While we're here, let's have a look at stop async. It's grabbing the current execution context, cancelling it, and then awaiting this is started to be false, because that means that we don't prematurely return from this method until it's genuinely stopped. And then skip forwards async, similar to skip backwards async, but a bit simpler, because what we can do is just take the total progress, subtract off the current exercise's progress, which gets us to the start of the current exercise, and then add on the current exercise's duration, which gets us to the next exercise. And again, we're just passing through is paused. To the start async method. Now one thing I have forgotten here is this on start async method, which is called by the command. This state could be a time span. So I need to check that and pass it through if it is. One other thing I didn't mention was I had to add a model property to our exercise view model. So I've added that property here. Obviously we'll flesh this out properly in the next video, but currently it just allows getting and setting through the constructor. And the reason I need that is because that's the only real quality semantics we have with these view models, is to check the model underlying it. And since I need to be able to check which exercise we're up to, I need to be able to compare the model in the view model to the model in our list of exercises. So with this in place, hopefully some of our tests pass at least, but I'm not holding my breath. Okay, something pretty bad is going on here. Not sure whether it's a test problem or some kind of mono problem. So I'm going to pause and look into this. Okay, I'm back from a rather lengthy and painful debugging session. So I found a couple of issues along the way. and I just want to point out what I've done here. So first of all, you may remember when we're writing start async, I mentioned that I was a bit worried about what would happen if the task here got cancelled, which is quite common for us because as soon as you cancel the execution context, you're effectively cancelling the task as well. Turns out that was an issue, and we need to kind of swallow the task cancelled exception here, because effectively we are handling this by resetting the execution context to null, because if you think about what the cancellation of this task means, it means that we've stopped our exercise program. So by setting the execution context back to null, we've indicated that to our view model that we've stopped. So that's cool. The other thing I found was another issue with toProperty. Same issue but a different property. Our skip ahead was previously using toProperty, and we had the same issue we had with I think it was progress. So I've swapped that over again to a public getter, private setter, and I will try and chase this up on the Reactive UI forums and figure out what's going on there. But in the meantime, that will do. The other thing I found was I was completely missing current exercise implementation. So I've implemented that as follows here. So it's basically monitoring the execution context, current exercise in the execution context. And note that it is important that we do both here, because if we only monitor this expression here, then if the execution context is set back to null, we won't be notified. That's why I've got this one as well. And basically what I'm doing here is checking if the execution context is null, then the current exercise is null. Otherwise we use whatever this expression resolves to. And of course I have to look that up through the model, because this is a model. So I have to resolve the related view model by comparing the model against that. So that's that. And finally, I've found a problem with the can execute logic for skip backwards, I think it was. No, skip forwards, can skip forwards. I was missing this expression here. So sometimes it was saying it could skip forwards even though there was no current exercise, which was a bad thing. So with all those in place, I've found that the tests work most of the time. There is one test that's failing occasionally. I haven't figured out why yet, but we'll see if that happens now. Yeah, it looks like it's going to fail. Okay, so this one failure here, whoops, is not always failing. So if I run that again, you'll see that it often passes. So I will look at that separately, but right now this video has gone on way too long. So I want to finish there. Obviously I'll tidy up a few things, change a few things after the commit for this video. So keep an eye on that. So I will see you in the next video.